Hello, everybody. Welcome to this session. My name is William Vabenep. I run the product management function for our data processing and experiences product at AWS. And with me today are Kinshuk and Craig, who they'll introduce themselves when they come and talk to you. But just to give you an overview of what we're going to discuss, this is going to be grounded in an announcement that happened in the keynote this morning. At the very end of the keynote, Matt Garman, he kept the best for last. He talked about the new SageMaker. This is what we're going to be talking about, and specifically the data processing part of that. So for those of you who missed the keynote, I know it went long and some people may have missed the end of it. I will catch you up and go a bit deeper on what was announced there for SageMaker. And then Kinshuk is going to come and talk about the data processing products that are under the cover, which are used as part of the SageMaker platform, and all of the improvements and new features, new capabilities that were recently added to those products. And finally, Craig will come to talk to us about how Bridgewater is using all of those products as part of their own data platform. So going back to this morning announcement, the part I'm referring to is the announcement of the new SageMaker. And so let me explain a bit, because many of you, I'm assuming probably all of you, know SageMaker as the AWS machine learning service. SageMaker is now a lot more than that. It is a unified platform for all data, AI, and ML services on AWS. And so everything you know as of yesterday as SageMaker is part of the new SageMaker platform, but it's now called SageMaker AI. It's one part of the platform. The platform is much broader, bringing together all our data processing products, EMR, Glue, Athena, MWA for Managed Airflow, Redshift, as well as Bedrock for Gen AI, all of them coming together as part of one platform with unified governance and with a data lake at its core. So a graphical way to think about it is those three key parts of the new SageMaker platform. The Unified Studio, which is what I'll describe most in this session, it is a new experience where data workers can use all of the features, data processing and ML, in one unified application. And I'll tell you more about that. Quickly, just to make sure that you have the full picture, I will say a few words about the other two parts of the SageMaker platform, but those are not the focus on this talk. There's other sessions that give you more detail about the governance aspect and the SageMaker Lakehouse. So starting with the SageMaker Lakehouse, which is launching today, generally available as of right now. What this is bringing together the data warehousing capabilities of Redshift, the data lake capabilities of using Iceberg on Amazon S3, unifying that into a data lakehouse. But actually it goes beyond the data in those analytical storage systems. It also brings all of your data in operational databases or even in services outside of AWS. And so thanks to Zero ETL, you can bring into the lakehouse data in SaaS vendors like Salesforce and SAP and many others. You can create federated data sources to access data in BigQuery, in Snowflake, and all other places. And so all of this data, from a consumption perspective, is available as part of the lakehouse through a standard-based unified consumption interface, which uses Apache Iceberg. And so this is open. This is standard based on the very popular Iceberg REST API definition, which means that not only, and obviously all of the AWS services that we'll talk about here today are able to access this data, it's also true for every service, every framework out there, which knows how to use and write data using Apache Iceberg, which at this point is pretty much every single service out there, thanks to the huge growth and adoption of Apache Iceberg. So there's a lot more to say about the lakehouse, but again, it's not the main topic, so I would refer you to the several sessions that are offered on the SageMaker Lakehouse. On top of the lakehouse, what we've also put, sorry, I went too fast. Here we go, we can do it. On top of the lakehouse is a unified governance framework. And so many of you may be familiar with DataZone, exists as a product today. DataZone has been brought at the heart of the SageMaker platform bringing all of its governance capabilities, bringing the business data catalog, the ability to browse, to document the data in a business term, adding business metadata on top of the technical metadata of the Lakehouse catalog, the ability to manage the quality of the data, to manage lineage, to manage data classification, but also extending those governance capability beyond data to ML system. And so this is now also the place where you go to manage Gen AI guardrails. It's the place for all the features that SageMaker AI provides for responsible AI, all coming together and providing a place of business governance for your data on top of the Lakehouse as the technical data management environment. Again, there are sessions about SageMaker Catalog, which is what DataZone is now known as part of the SageMaker platform. There are several sessions about the governance and collaboration capabilities that the DataZone catalog offers by building on top of what DataZone was previously offering. The focus today, sorry, this button is all sensitive. I'm going 2 slides at a time. We can do it. It really wants to go forward more than go backward. Okay, I'll go straight to that one. Let's talk about the SageMaker Unified Studio. Unlike governance and the SageMaker catalog and the Lakehouse, which are both shipping as GA as of today, the Unified Studio is shipping in preview. We will follow with GA very shortly, but it is a public preview available today. Anybody can go and start using the Unified Studio. What it is a single experience for all our data processing products. Now, you see on the right side, some of them are marked as coming soon. So if you go use SageMaker Unified Studio today, you will not find streaming, you will not find BI, you will not find search. They will be coming later. For now, it's the first 4 on the left side. It's data processing, what today you can do with EMR, Glue, Athena, MWA. It is SQL analytics with Redshift. It is everything that was in SageMaker previously, plus more. And it is everything that was in Bedrock previously, plus more. So those are the services, those 4 on the left side, that you're going to find today in the public preview. One thing that's important, that one of my goals here today in this session, is to help clarify the relationship between the old and the new. Because obviously in the keynote and in a lot of the blog posts, we talk a lot about the new part, and the Unified Studio is new, and we'll talk about that as an experience, as a web application, as a set of graphical tools. But it is based on the same data processing, AI, and ML services that you are already using. And so through the Unified Studio, you can use EMR for Spark and Trino and Presto and Flink and all the things that EMR provides, both using your own cluster or using a serverless system. You can use Athena. You can use MWA for managed airflow. You can use Glue. You can use Redshift. So under the cover, those are the battle-tested services that and that are secure, are scalable, and are reliable, and as opposed to a brand new kind of execution environment. It also means that your current application, your existing data, your existing clusters, your existing pipelines, all of this can come and be used directly in the Unified Studio. This is not a new environment where you have to start from scratch and rebuild things. And so, from an adoption perspective, it's important to us to have a smooth onboarding onto this. As we were building Unified Studio, the rest of the team kept iterating and improving the underlying services across all of those. And so I'm not going to talk about the improvements to Redshift, to SageMaker AI, to Bedrock. Again, other sessions cover that. Today, Kinshuk is going to cover the left column, so I'll leave it to him to talk about the improvements to the underlying data processing services. I'll talk a bit more about SageMaker itself. And again, 2 slides in. This is a little, here we go. So SageMaker Unified Studio is one environment for all of your data-related processing activities. And so today, if you look at what the existing products, or today I should say yesterday, if you look at the portfolio as it existed, you have EMR. It has the EMR console. You can, in the AWS console, you can use EMR Studio. You can use Glue Studio, Athena, Bedrock. Each of them has their own UI. which works fine as a front end for that service and for what it does, but most of the data processing activities require the use of several of those services, and then you're kind of on your own to put them together. Whether it's the same person using multiple tools and having to go from one to the other, or whether it's different people with different skills and different preferences and tool set collaborating. One way or the other, the integration was left to you to use all those this very comprehensive set of services. That's what's changing with the Unified Studio. So let's look at what it looks like in practice. This is the login page. Not very exciting. Actually, exciting in a way, because one thing you'll notice is this is not part of the AWS console. And so this is an environment built from scratch for data workers, many of whom really have no business in the AWS console. It is an environment that, it's a web application. You have one URL, you go to, and you start using it. And the second thing to notice here is you log in using your SSO credential. This is a place where you come and identify as an individual, using your enterprise credential, and everything you do, including all the Git commits and the access that you get, is based on you as an individual, which is really a much better way, using SSO accounts and groups, and a much better way to organize things. And again, I went too fast. Here we go. The second thing I want to show, which is part of the core organizational principle of SageMaker Unified Studio, is the notion of project. Those of you who use DataZone already will recognize project, because that concept came from DataZone as part of DataZone being integrated in the SageMaker platform. It is a place of collaboration. It's a place where you can bring data, where you can bring artifacts, whether it's a pipeline, a SQL query, a model, a GenAI application. You can bring the artifacts that you've created, or you can create them directly in the project. You can bring compute, a cluster, an EMR cluster, a Redshift cluster, or a serverless endpoint, for Athena, for EMR, for Redshift. You can bring all of those into the project, and that becomes the boundary of collaboration to make it very easy as you add someone to a project to make them productive right away and have access to all the data. Every project is backed by a Git repo, and so anything you change, is version control and accessible through the Git repo. And Amazon Q is available throughout the project. So you see that little purple button on the upper right. I'll talk more about the specific capabilities, but throughout the experience, it was built with Amazon Q being pervasive and helping you at every step of the way. So let's look at a bit more. Before we go into the actual tools, and other part of the SageMaker Unified Studio framework is the data browser. And really, this is where the lakehouse that I talked about earlier, the SageMaker lakehouse, this is where it shows visually. Because what you're seeing here, and sorry, I know it's small, so I'm not sure if everybody can read everything, but what you're seeing here is, in one place in your project, access to all the data that has been shared with the project, including data in your lakehouse, whether it's Iceberg data on S3, whether it's data in RMS, including federated sources. I think here we have, there's BigQuery, there's Snowflake, example of federated sources that have been brought to the project and appear as catalogs in the data browser, as well as data that is brought in through zero ETL integration. And so now here you're seeing the lakehouse with all its richness coming together with centralized fine-grained access control and with the ability to use all of the tools on the data. So you right-click on any of those and say, open in a notebook, run a query, and start working with them. Let's talk about some of the tools. There's many tools. There's more than those. Here today, I'm going to focus on the tools that relate to data processing. So I'm not going to show you the part of SageMaker Unified Studio that brings in model training capabilities from SageMaker AI, GenAI application development. There's a lot there that I'm not going to show. I'm going to focus on the left side on the tools that are the interfaces through which you consume data processing services. Starting with the notebook. Notebook is probably the central tool, at least for many people. There are people who come there just for SQL, but Notebook for many people is really the central tool. As of yesterday, we had plenty of notebooks. EMR has notebook, Glue has notebook, Athena has notebook, SageMaker had notebook. And so it meant that as a user, like it was easy to get a notebook, but you had to pick the notebook that corresponded to the services you wanted to use. And really, that's kind of pretty cumbersome. Now, there is a unified notebook in SageMaker Unified Studio that you can use to use all of those services. And so it's one notebook. You can, thank you for the thumbs up, I appreciate that. There is one notebook that is polyglot, and so the cells can be, you can have a SQL cell, a Java cell, a Python cell, a Scala cell, and then you can attach the corresponding runtime that you want to use for those given cells. And you can, from the notebook, use all those services. You can do data engineering, you can do feature extraction, you can do data science, whatever tool you want to use, and mix and match the underlying services. You can also create workflows. And so one of the services is MWA, which is our managed Apache Airflow service. Through the notebook, you can create an Airflow DAG and use MWA to orchestrate the workflow. You can access the Spark UI, you can access your Spark logs. You really have everything you could do from any of the other tools, you can now do through this and more. We have added new features. We've also added, I mentioned earlier, queue integration. And so you can use queue pretty much for any task that you want to do here. You can have queue generate code for you. You can have queue explain code for you. If somebody else wrote code that you're not quite sure why it's doing that, you can just ask queue to explain it to you. You can have queue help you refactor code. Basically, every task is assisted through queue in the notebook. Another tool that's available in SageMaker in Unified Studio. This one comes from Glue. Those of you who use Glue for data integration know that in addition to the code interface, Glue offers a visual ETL that allows you to, through drag and drop, select your sources and transform your data, filter it, or other transformations, and then bring it to a destination. That is also available in SageMaker Unified Studio. And just like in Glue, you can execute from the visual representation, or you can translate it into a code representation if you want to have more control and do your edits after the graphical creation. And guess what? Queue is there as well. And so Queue, based on a natural language request, can generate a visual workflow for you as well that does what you're trying to do. And at least as a starting point to get you started, and you can add filters or other transformations as you see fit. Let's talk about SQL queries. Very similar story. Redshift today has a query editor. Athena has a query editor. You know what I'm going to say? There's one unified query editor which can be used to run queries in Redshift, in Athena, with visualization of the result. Again, with Queue assistance, so you can ask Queue to write SQL for you based on your natural language description. And that's informed by the content of your catalog. And so you can refer to your tables in kind of business terms. I'm looking for customers in this country who have spent more than so much. Being able to use kind of business terms as part of the description, that will generate a query using actual table names, and that's ready for execution. All right, a couple more things. I mentioned that the data zone governance capabilities are part of SageMaker, the overall new SageMaker platform. That means that those capabilities are now available through SageMaker Unified Studio. So here's an example of those governance capabilities. This is the business data catalog. Sorry, it's probably very hard to read. The point is not to read the text, but this is the business metadata about your data set. As opposed to, or in addition to the technical metadata, that schema and information like this, you can yourself bring business description and curate your data. You can have Queue generate it for you and suggest a description that you get to review and accept or edit to help prepare it. And then you can publish this data in the business data catalog, allowing others in your domain to discover the data. And then when they find data that they think is useful to them, there is the capability for them to send a subscription request for this data set, which will automatically trigger a request coming to the data owner, who will review the request and decide to grant it or not, or potentially to grant it, but with a filter. And so, for example, if you request access to a customer table, the owner might say, well, sure, I'll give you access, but I'm going to add a filter. You can only access those columns, or you can only access customers in this country, and you put a filter to limit the rows that are accessible. And so the idea here being that the fine-grained access control can apply as part of this workflow to subscribe resources. And then everything else, again, this is now a talk about governance, so there's many more capabilities, including lineage, including data quality, including responsible AI, including guardrails for Bedrock, and all of those come together and as part of that unified UI. And so in this place, you can, this is the right place for a developer, for a SQL analyst, for a data curator, for really everybody who's a data worker, and allow them to collaborate. So that's a quick overview of the Unified Studio. Like I said, the execution of all this is based on our powerful data processing, ML and AI products, and Kinshuk is going to tell you more about the underlying data processing services.
Awesome. Thanks, William. So what is new in data processing? So we talked about Unified Studio, and as we actually, as you browse through the Unified Studio, as William said, you are going to see your name as you do a single sign-on. And then all the tools that are available there, the query editor, the notebook, they are all powered by the underlying data processing engine, that is Glue, EMR, and Athena. So you are able to connect your notebook to an existing EMR EC2 cluster. You are able to author a low-code, no-code job and run it against a Glue engine. You are able to author SQL queries and run it against Athena or Redshift. Now, continuing on the innovation theme, at the processing layer, we focus on three specific areas: continued investment in performance and cost, operational excellence and security, and then beyond the code authoring that you all have seen, we are launching some new Gen AI-based capabilities to make the life easier for a data engineer. So let's start with the best performance at the lowest cost. The biggest reason customers prefer running their Spark workload on AWS is it makes it easier and it is fast. And with the latest announcement, the AWS managed Spark is 3.9 times faster than the open source Spark equivalent when you run it against an EMR engine. The key advantage here is that, as you know, most of the billing is based on compute hour. If the underlying engine is faster, the compute hour requires to process your data are going to be lower, which means your cost will be lower. We have done similar innovation on Trino engine, which powers our serverless SQL service on Athena. So the 2.7x improvement, the Athena Trino engine is 2.7x more performant than the open source equivalent. Graviton 3. So we talked about the engine-specific enhancements. We also are doing similar things on the compute level. So Graviton 3 offers out-of-the-box 20% better performance that leads to reduced costs for your large-scale jobs. And all of this is available while maintaining 100% open source compatibility with the engine, which means there are no surprises when you move your existing workload over to EMR or to Athena. The second aspect that we delivered this year is around managed scaling. Now, folks who are familiar with EMR, they already know we already support auto scaling. So what is unique about managed scaling, you ask? Number one, we made it much better. So the auto scaling feature that EMR had, we shrink the delta between when we decide to shut down a worker from actually acting on it. So now there is a faster scale down, which means that your compute cost is further reduced. Some of the customers are experiencing as much as 60% cost saving because of the improved auto scaling algorithm. We have done similar improvement on MWA, which is the Apache Airflow service. So now with the left graph that you see is that the task count, the moment task count goes down, at the same time, your worker count goes down immediately. So there was a lag between the task count and the worker count. We actually have reduced that lag to nearly zero, and now you actually are able to save cost even more. One of the key asks in Glue had been about, I have a recently hired person or I have an intern, and I want to make sure that the intern should not be able to kick off a 200 node Spark job. So we launched something called usage profile this year, which allows you to create profiles like an intern profile or a new hire profile or a QA profile, which means that you can assign a persona to the compute usage or the duration of the usage or the session count and so on and so forth. This is more about a proactive cost control versus a reactive cost control. Here, once you assign this persona a usage profile, they will not be able to launch bigger clusters or longer duration jobs. Okay, let's talk about operational excellence and security. So one of the key challenge in data processing is about fine-grained access control. So at a very high level, fine-grained access control is about allowing administrators to create policies which are enforcing access at a cell level, which is combination of row and column. Now, achieving fine-grained access control at scale is difficult. And primary reason, I'm going to use Spark as an example, but primary problem is that Spark is very developer friendly. It allows you to sort of mix imperative and declarative code, which means user has a lot more control over the data that they are manipulating, which is what makes Spark super popular because it's so easy to actually manipulate the data using Spark. You can embed UDFs, the user-defined functions, into the query plan, and those UDFs have access to memory space. And what we have done is we have shipped a Spark native fine-grained access control. So this is a key innovation that we delivered this year, where we have segmented the cluster into user space as well as system space, which means the policy enforcement is only allowed at a system level, and user can continue to define the functions, continue to sort of write those functions, but enforcement of those policies can execute at the system space, basically allowing fine-grained access control to happen at massive scale. I'm talking petabyte scale of the data. If you want to know more about this, we have actually written a paper. It's available on Amazon.science page, which you are free to check out, where we talk about all the challenges that we have with the Spark-based data processing system and achieving fine-grained access control there. Concurrency and queue management. I get asked this question a lot of time. Why do we have limits in serverless offerings like Glue EMR serverless? One of the reasons is that we want to protect a runaway job from consuming too much compute and thereby creating a large bill. So pretty much, Glue and EMR serverless, I'll just take two examples where we actually have limits to protect the customers from having to, run into a situation where a misconfigured job or someone forgot to actually turn off the machine lead to massive error. And in serverless, that's it's very much possible. So what we have done is we have introduced both in Glue and EMR serverless a queuing solution, where if the job doesn't have sufficient resources, maybe it doesn't have sufficient compute or memory, the job will be queued for when the compute and the memory is going to be available. So the queuing and the concurrency management, it is available in Glue and EMR serverless. Finally, I like to end with the flexible deployment option within EMR. As your data processing need vary, it changes based on the SLA that you have with your teams, or based on the cost profile of the job. Some of the jobs are SLA sensitive, other jobs are cost sensitive. EMR offers you a variety of compute options. You can pick from serverless, EC2, EKS, Spot instance. You can run it on Graviton 3. And you can actually have purpose-built instance types like support for, for your batch job can run on general purpose. We have memory-intensive jobs, bigger joins with large amount of data that can benefit from memory-intensive EC2 instances. Basically, your job or compute profile and system profile for every kind of workload that you have. Okay, so finally, let's talk about Gen AI-powered innovation. So earlier this year, we launched the Gen AI-powered authoring experiences, both across Spark as well as SQL. In case of Spark, you can write jobs like create an ETL pipeline that moves data from S3 to Dynamo and apply insert apply mapping transform. These kind of natural language prompt will lead to an ETL pipeline that you can actually execute and configure. Similarly, on SQL experience, you can figure out, hey, give me the top 10 sales figure from this table, and it will translate into a SQL query. So code generation is awesome, but we made it better. The primary problem, there are two problems we are trying to solve. One is code generation is done, but what happens when my job fails? What about root cause analysis? And the second problem we are solving is how do I get the latest and the greatest by upgrading to the latest Spark version, which has probably support for the latest table format like Iceberg, support for better performance, et cetera, et cetera. So using Gen AI, we just launched this feature last week where we are planning to solve both of these problems. So instead of talking about this, I do have a demo which I'm going to play. But the idea behind root cause analysis is that the time required to look at a Spark job failure could be weeks, if not months. One of the problems with a distributed programming construct like Spark is that one line of code error could lead to 100 pages of error messages, which are very difficult even for the most experienced developers to parse through and read through. And the idea of using generative AI is to sort of deploy it so that you can actually automatically do the root cause analysis. So let me just play the video. Let's see if it works. OK, so here's the Spark code. And it's a standard Spark code where you're ingesting data from some S3 source, and you have a failed job run. And here you see a troubleshoot with AI button, which actually identified the root cause to say, hey, you know what, I see resource not found, which means that a resource is probably not available. And here in this case, this was identified. It actually gave you the row number or line number of 18, and you found a typo there. You saved the job, and then you ran it. Now, in this case, the root cause analysis is very elaborate. It actually tells you exactly the line number where the error was found and what kind of error was it. And based on that, it actually generated that report. And as you can accept the changes, you can run this job, and you can see now the job succeeded. Now, the second place where we have done the similar innovation is on upgrading the Spark version. Now, with each Spark version upgrade change, there are fundamental changes in the API. Sometimes the changes are in the function call. Sometimes the changes are in whether it's accepts an integer or float or those kind of changes. So the idea, the typical data engineer, the way they upgrade the Spark is let me upgrade to the latest version, run the job, find error, fix error, rinse and repeat. So there are multiple rinse and repeat with every single job failure. You are you're analyzing the failure, you're looking at the error code, changing the code, and then trying again. What we did was we unleashed the Gen AI to do this. And again, I'm going to play the video. OK, so here you have a job, and you're going to say run upgrade analysis with AI. And here you are specifying what would be the result, like where do you want to store the resulted code, the upgraded code. So when you run this analysis, the interesting thing is that it's not only going to tell you the resulting script, it's actually going to tell you all the failed instances. So it will run the job on your behalf, understand the failure type, make the change in the code, rerun the job, identify new failure type, rerun the job, and it actually leads to the successful job run. And it does it automatically without any intervention from you. So this feature is available in preview right now, and you can check this out in the Glue interface. So it's showing you the failed jobs. So these are all the failed attempts it made. And every single failure, it learned what was the failure cause, and then it actually modified the code, upgraded it. And finally, for those who really want to see the code, there is a result screen where you can actually download the diff of what was the before version and what's the after version and compare the results. So with that, I'm going to hand it over to Craig, who's going to talk about Bridgewater.
Hi, everyone. I'm Craig Sahanek. Should go to my slide. I'm an architect at Bridgewater. I'm going to talk a little bit about how we use some of these data processing tools to solve some of our problems. Now, I imagine many of you don't know who Bridgewater is, so just give you a quick overview of who we are. The way I would describe us is we're a systematic global macro asset manager. And that's a lot of buzzwords, so let's sort of like break that down a little bit. Asset manager, we manage money for our clients. We buy and sell assets, to meet their investment goals. Systematic is how we do that. We build models of the world to understand the world's economy and then make decisions based upon those models to buy and sell assets. And then the global macro is the type of assets we're buying. And the easiest way to, and the type of bets we're making. The easiest way to explain that is like just example based. So we'll take bets on, is the US dollar going to go down versus the euro? Is the US equity market going to go up? Is the Japanese bond market going to go down? And we're running systems using our models to make the decisions to buy or sell those assets, which is different than a lot of asset managers where you have individuals making those decisions. Instead, we have a compounded system that the system is making those decisions. And when I'm talking about models, there's two ways I would describe the models that we're running. There's a lot of talk about AI models here today, and this is not a system that is using AI. This is a system that has been built up over 10 years of our expertise, but also 40 years of us building a business and understanding how economies work. And the pieces of it are, it's fundamental. We want to understand the causal relationships. We want to understand what drives economies, what drives asset prices, and use that to make the decision. And it's an expert system in the way that that system is built. The other part is it's universal, and universal in sort of two different dimensions. We have through time. We're not just looking at today, what do we think the prices of the assets should be, what the economy is doing. We're looking back through it, through all of history, as much of history as we can actually have, and have the model run and say, this works in all times, in all economic conditions, because we never know what the next economic condition is going to be. We may experience the same economic conditions we experienced 50 years ago. And we're also doing it dimensionally. We're going to look across all the countries in the world, all the markets in the world, and the same model is going to run against all those different dimensions that we have. To make that a little bit more concrete, let's look at an example model. Inflation. We always hear about inflation in the news. Inflation's up, and the Fed is targeting a certain inflation rate. And what is actually being talked about in inflation a lot of the times is the consumer price index, or the CPI number. That's the number a lot of the times you hear the US government releasing every month and saying this is where the inflation number is. And of course, we want to have our own model of CPI because we don't want to just rely on governments to tell us what it is. We'd be behind where the numbers are because those are only released every month. But we also want to have a unified model that looks across, what do we think inflation is in any given country. And the way we can then think about inflation in those cases is like we can break down, into different categories. So we have a headline total inflation, then we have a core and a non-core, for example. And we say core things that people have to spend, things like food, energy. Non-core, things that are more discretionary that maybe they're not going to have to spend. And we're going to keep breaking down that and use data sources from any type of data provider that we can, that makes sense for us to use in any different thing, and aggregate things from the data provider. Maybe we're going to pull what people are paying at the grocery store, or what they're what they're paying at the pump at the gas station, or what they're paying for electricity rates. Aggregate that up, transform that data to form a view of what do we think that actually translate to the effective effect on their pocketbook of what the inflation they're experiencing. And we have lots of these models. We run over 1,000 of those models continuously. And that translates to something about 2 million model runs running every year. And that's producing a lot of data. That's producing 300 million tables of data, carrying 19 petabytes of data a year. And that's growing. And it's growing because we've been enabling our systems, enabling us to analyze more data with our systems as we build and run this every day. And the growth rate is pretty incredible right now for us. Right now, we're growing at about 5% new models. Over the last 6 months, we've grown to about 5% new models we're adding. But it's also 30% in growth in the number of tables that we're writing out from those models, and 80% growth in the amount of data. And that's not slowing down. And that's being enabled by the systems that we built on top of AWS. And to sort of talk a little bit about, these models are not independent. They're interconnected. And it's really important because these are the models that are making decisions of what assets we're going to buy and sell. Then we have to make sure that they're producing the correct data. We have to understand when the data is wrong, or when we experience anomalies in the data, what is wrong with it? Why did this happen? And we need to dive into it and decide, what do we do? What do we do when a piece of data is wrong? When we think the U.S. economy, U.S. inflation jumped to 100%, is that right? Probably not. Let's go figure out what happened. Dive in and say, do we roll back the data? Do we use yesterday's data rather than trading on the newest data? Do we have a bug in the model and have to go fix the model? Do we have some data provider provided us some bad data and we have to go fix that data ourselves? There's a lot of decisions we have to make, and we have to understand where the problem is in order to do that, and then make decisions quickly, because we have to get to the market to understand we got to buy and sell assets quickly in order to go do that. And there's amount that we can do that automatically, but the real key is we have people in the loop, people who are making these decisions, operators whose job it is to make sure that we are delivering the up-to-date information every day. It's got to be correct, and it's got to be on time. The longer, we lose liquidity in the markets if we don't get into our positions in a timely manner. And if we trade on that the U.S. inflation went up to 100% yesterday, we're going to make bad trades. So we have to be correct. And these aren't just operators who are pushing buttons and just making sure, like, yep, the model just ran. They have deep context. They understand how the models work, what they're doing. They also have to understand the markets, and they have to understand the economic data. They have to say, hey, when that inflation number jumped, is that right or is that wrong? Maybe there's activity that's going on in some market that says, the Netherlands GDP is going up big time, or there's all kinds of different things. So they're very contentful, and we need to enable them to be able to use their contentfulness. But since they're contentful, their time is also very valuable. This is not something just anybody off the street sort of job can do. They're experts in their field. And so we build tooling to enable them to do this. And what we do is we build diagnostics, we build visualization tools that are built on top of some of these technologies to understand the relationships between the data. They need to be able to dive deep into those relationships and interact with it, because they need to follow their sense of what is wrong with the data. Where is potentially this model going wrong? Is there some root cause of this? Can I follow it to the root cause and figure out what I need to do based upon that, what decisions I need to do? And that means they have to pivot data, they have to drill into data, and they have to follow the relationships as much as they can. So let's go back to our inflation model and talk a little bit about what these models are producing. And I mentioned earlier, we're producing tables of data. And you can sort of see from this view of like, this is what a model will produce at the top level, but we produce it for every calculation that we do. And there's a couple key pieces of information to look at here. Each of these cells, which I have not bothered to fill in the details of all of them and not bothered to show all the columns, but each of those cells is not just a single value. They're a rich time series of data that we need to process through and get the right piece of information to the user, which means these tables grow to a large size, particularly as we have a lot of data in any individual cell. We see that there's a relationship between the rows. In this case, we're dimensioned on country, but we can dimension on any dimension that the users would want to do. And as we drive deeper into the model, there's probably more dimensionality hidden within that. But then there's also a relationship here that on the top, we have a relationship that we can see that total CPI is an aggregate of core and non-core CPI, but that's not exposed in the table because now we just have a table of data. And the operators who are looking through this, trying to understand the relationships, they need to drill in and know that relationship. And that relationship is not always as obvious as it is in this case. And so our tooling has to join these tables of data, which we have stored in orc files in S3, and join sometimes to itself, sometimes to other tables, to show them the relationship and so that they know how to diagnose into the aggregates. So we have a problem. We have a lot of this. We have a lot of tables of data that we're producing every day. These tables are immutable, so every new day we produce a new copy of that table, hence the large number of those tables. But we need to analyze that data. We need to enable these users to analyze it quickly. So there's sort of like three basic things of like how we have to solve that problem. We have to have scalable infrastructure. We have to have scalable infrastructure for basic cost reasons. We have spiky loads. There's going to be a higher load during business hours when markets are open, when economic activity is happening. But also when economic events, we're going to spike even more. When there are big moves in the market, we're going to run more, try to get the data up to date as fast as possible. But I also mentioned we're scaling the amount of data that we're processing. There's an 80% amount of growth of data that we're producing every day. And we have to process through that data anyway. And it's continuing to grow. So we need to have infrastructure that's going to scale for us. We also have to be efficient about how we operate across that data. We can't possibly process every piece of data in detail the way that you would need to process that data. We have to make sure that we're processing the right data. And a side effect, or another part of that is we need to anticipate what users are going to do. We need to pre-compute because the physics of some of the processing that we're doing here is just impossible to return the information to the user within the time window that they want to. Because remember, we have these operators who are experts in their field, who are trying to understand what is going on in these models, and we can't stutter on how, when they're trying to dive through the information. If they click and they have to wait a minute, their brain is somewhere else. We have to react to them. And so but we have processing problems that are literally, we could not, even with unlimited computing resources, compute fast enough to do that. So we have to pre-compute some of the information. We have to get ahead of them and make it seem like that we're reacting to them and get it done before they do. And so the technologies that we use to do this is really, Trino is the heart of a lot of what we're doing. It's really enabled us to do a lot of what we do. The relational algebra through the SQL interface is really is what we use to generate the visualizations for the users. It is key for us to be able to go from a world where we were not using relational algebra to a world where we were, in order to go through this data and build on top of it. Rather than building a custom database engine that has its own sort of constraints, building on top of something like Trino has been invaluable. The other big part of this is the way that UDFs work with Trino. When we were building out the system, we were looking at many different systems. And one of the other systems we were looking at was like, hey, could we just use serverless? Could we just use Athena, off the shelf versus using Trino in EMR? And the UDF capability that we have within within Trino is a key component because it allows us to bring the processing to the data more closely. When you look at Athena, it also has UDF capability, but you have to do it through Lambda. So we would wind up pulling a lot of these large series of data across the wire to the Lambda processing, versus with the UDFs, we can select just the data that we need, pull it into the node that is doing the processing, and be efficient about the operation. Another part of this is Trino scales. We can configure how it scales, but it also scales based on map reduce jobs. It's a map reduce paradigm, so we can scale the worker nodes, we can scale the master nodes, and do it all based upon what workloads we need to do. And we have different type of workloads, so we can configure the clusters for the different type of workloads that we have. It's also very efficient at how it operates. Through things like predicate pushdown means that we are not going to select out of the S3 bucket, read back that data, things that we don't need to read out. And so the efficiency of Trino is a key part to it. And then also, it compounds. We have built more than one visualization tool on top of it already with a common engine because we have a SQL interface to this data. And then we're using Trino within EMR, and EMR gives us flexibility. I mentioned that we have different type of workloads, and so we have multiple clusters that are configured in different ways. And it's very simple for us to do that configuration. We're a small team. We don't have a lot of, we have a lot of generalists, not people who are very, just deep in one technology. And it makes it very easy for us to just have anybody who is familiar with the primitives, the configuration, get in there, work on it, tweak how we're doing it, configure the services, and help us build out and scale the services as we need. And something I don't want to undersell is the ease of upgrades. Like many organizations, we struggle with upgrading our technology at times, keeping up to date on the latest libraries. And I have to say, our upgrades of Trino have been and EMR have been some of the least painful upgrades that I've had. I remember there was a bug that a bug in one of the versions of Trino, so we wanted to upgrade to a later version. I was expecting that to be the normal. It's going to be a couple sprints, and it's going to cause problems, and of course, and then I went to the team hey, we need to get this upgrade done. And it was out there the next sprint, and it was just the ease and the transition that EMR has given us to follow those upgrades is a real big lift for us. And then finally, I'll talk a little bit about Glue. Glue is the glue, pun very much intended on this, of how this sort of hangs together. We use it as the data catalog because we're running multiple clusters and we're trying to do a bunch of pre-work for it. It allows us to just do registration once, get these tables that we're creating lots of new tables constantly in the system, get them registered into our catalog and make them usable for any of the different workloads very easily. And if I was doing this talk 6 months ago, I probably would just have ignored Glue a little bit because it was probably a thing we thought was a weak spot in our architecture. It was a place where we thought we're going to need to replace that with something custom. It's something that we thought was not good enough because we were seeing performance problems with it. We thought our scale problems wouldn't work with it. I was very bearish on Glue then. I'm very bullish on it now, I will say, because we spent over the last 6 months, we got into it and figured out a couple different things. One, we're using Glue wrong, which is a lesson I think everybody should learn is one of those questions you should ask yourself, is it the technology or is it the way that you're using the technology? And this is one of those cases where we were using the APIs in ways that they weren't intended to be used. And then, of course, we were seeing performance problems. We were seeing things that we wouldn't expect. And we use Glue in a very different way than I think a lot of other people use Glue, which is we are pushing in millions of tables every day and evicting millions of tables out of it. And we were trying to keep the eviction process was actually one of the things that we were hitting the limits of Glue and we were worried about we would run out of. And one of the reasons I'm very bullish on it now is one, we figured out our own problems, but two, it is a part of the architecture I don't have to worry about too much anymore. I was worried we would have to go build our own data catalog solution that was going to be cross-AZ resilient. We had looked at using Hive, but that wasn't, the Hive native data catalog, but that didn't have the cross-AZ resilience as well. And I was like, oh man, we're going to have a big project. We're going to have to put a lot of engineering effort and a lot of management effort behind it. But now, I don't have to worry about it. And that's one of the best things you can say about any technology, I think, particularly if it's not a differentiating technology. So I want to talk just a little bit just to wrap this up, or to sort of walk you through the architecture of how this sort of hangs together. So we have models, they execute. When they execute, they write their tables of data, there's the org files into the S3 bucket. But then they also do something. The model calls a warming service and says, hey, I just created a bunch of tables, go get this ready so that visualization is going to come. The first thing that does is that goes and registers those tables into Glue, but it also makes a call to Trino to do some execution. Because one of the things, remember, we have those tables that have these rich data cells, which make these rather large tables potentially. But a lot of the time, all that we're really caring about is the last point of data. The users, the operators, when they're going to go look at the values in the visualization, the first thing they're going to look at is what changed today versus yesterday. And so a lot of times what we want to do is go execute and just slice the table down to single scalar values, which makes it now much more efficient for us to go execute against when the users are coming in for the visualization. But we're also going to anticipate. The model is going to say, hey, I think I detected some anomalies that are going on here, things that one of those operators is going to go look at. Go prepare. And so the warming surface is going to basically go pre-query those views in a background cluster, and use as much capacity as we can, use up all that compute that we can to go execute that data and store that into Redis so that we have it ready. So that when a user comes in through one of these visualization services that help them diagnose, they'll hit this query service, and the query service will be like, oh yeah, I already have that information. And they'll just have to pull it out of Redis rather than have to go to Trino, do the raw things. But they may also have new things that we didn't anticipate. And that query service will then combine that information into a view. But it will also do the same thing again, is that it's likely that the user is going to want to go where now? What's the next thing the user is likely going to go want to do? Or the user is going to make a decision like, oh, I want to pivot this data. I'm going to change the data. So maybe we don't have the exact view cached, but we've already sliced the data in some sort of way. We've already made the data ready and available so that we can be efficient in the way we operate. And then finally, the last thing I will just very quickly point at is we also have this metadata maintenance. We are producing a lot of data. We're producing a lot of new tables. Hundreds of millions of tables a year. A scale that we don't really even want to keep in the Glue catalog. Data very quickly falls out of usefulness in terms of, we've produced a table today, tomorrow it's going to be useful because we're going to want to compare against it, but then very quickly it falls off a cliff in terms of how much we want to use it or how ready we need to do it. And we are much more willing to tolerate, hey, we have to go register the table again, we need to go reslice that data again, if a user wants to go look up something from last month, last year, or something like that. So it doesn't have the same time constraints that we have with the active processing. So we have this metadata maintenance job that's keeping the Glue catalog clean and making sure that we're only really having the things that we're likely to need. And we're doing the same thing of cleaning up the S3 bucket. So to wrap it up, I really do want to say, AWS has really been important to us because we have a small team. We don't have to build a lot of the technologies. AWS helps us do it. It's been transformational to how we have been able to scale our business and scale the processing of the information that we have. And AWS has been a great partner to us as we've gone through this. They have really helped us understand what decisions should we make? What technologies should we look at? What technologies should we try? And are we using those technologies well or not? And then when we're running into places like, hey, the glue limits, where can we expect the glue limits? How can we architect our system so that we can so that we can meet those limits? And so I just want to say they have been an invaluable partner, and thank you.